Welcome everybody to Rust Night. It's 7 o'clock at night, and we are going to learn a new programming language. The programming language is called Rust. Rust is similar to C and C++, but it has better safety guarantees than C and C++ have. Back in the 1970s, when Bjarne was making C++, and I think it was Dennis Ritchie making C, they had a meeting back, I think in like 78 or 79 or something like that, where they were talking about the problem of arrays. Because an array in C is a pointer to the beginning of the array, and that's it. There's no information about where the end of the array is. And so that, lack of a solution, almost 50 years ago now at this point, has resulted in thousands, if not millions, of security violations, compromises, out of bounds memory errors, things like that. Rust provides very good guarantees, and if you do go out of bounds, it'll just kill your program without having to go to the extent that Java does. So Java and C# used they're what's called a garbage collected programming language, which means you knew things, and then the language itself will kind of figure out when to delete things. It will pause the program, look at what pointers can point to what things, and if there's things that can't be reached, then they free them. And so C#, thank you. Yes, sorry, it's pronounced C#. So I also call C# Microsoft Java. That's another good word for it. But Rust has taken a different approach. So Rust really reminds me a lot of C++, kind of, that doesn't have the bad defaults that C++ has. So C++ is famous for having bad default settings on things, and Rust, to a certain extent, fixes some of those bad defaults. So, for example, what do I mean? Let's go ahead and take a look at a brand new Rust program. Although I do kind of want to keep looking at CrabRave in the background here, so maybe we'll take up half the screen. I don't know. It's be exciting. So if I open up a file called hello.rs, rs is the file name extension for Rust. I can make a new program called main. Sound familiar? And Rust functions start with fn, which means function. And the return type actually comes after the name of the function. And C++ has actually adopted this. So because of Rust, but we've adopted this in C++, where you can actually have a trailing return type. And that's actually nice if you don't know what type your return type should be. Because if the type of this is like, some generic, then you have to return something of the same type of that. And so there's actually good reasons to have the return value on the right-hand side, even though I kind of hate it. This is a thing that is possible in C++ now. None of you guys may be seen it, but you can actually do this in C++. Okay, so anyhow, so here's main, your standard main, like we're doing in C++. The cout function is called println with an exclamation mark. The exclamation mark means it is something called a macro, which is not a function, actually. It's a preprocessor directive, if you want to think about it that way. Like in C++, when you do like hashtag define f of x to be like x plus x or something like that, then anytime you have f of 5, the preprocessor, the actual thing that runs before the compiler runs, will actually replace this code with code that's 5 plus 5 in C++. Anytime you see something with an exclamation mark like this in Rust, it's a similar sort of preprocessor macro function thing that, okay, the crowds are getting a little distracting. That is nevertheless more powerful than the preprocessor in C and C++. The kinds of things you can do with these macros in Rust is actually quite impressive. You can actually add extensions to the programming language itself and stuff like that. Like, it's actually pretty amazing. What you can do with a hashtag define in C and C++ is a lot more limited. Okay, so now here's hello world. If we want to compile it, we use the Rust compiler, Rust C, and we type hello.rust, and we run hello, and we get hello world. It does not default to a.out. It defaults to whatever the name of your file is as the executable. So it automatically builds an executable called hello, not hello.rust. Okay. So most of the time, though, most people don't actually use Rust C manually like this. Almost always, people in Rust use a makefile kind of thing. And what's really cool about Rust is that there is a standardized way of doing a makefile, of handling dependencies and all this kind of stuff. It's called cargo. And so history pipe through grep cargo. So cargo, I don't want to make the same. I've got a foo and a bar already. Somebody give me the name of our project, please. I can't think of any names. I'm out. Voss it is. All right. So cargo is pretty darn cool, and I kind of wish there was something like this in C++. So when we say cargo new Voss, this creates a brand new project. And it's not named after you, Voss. It's named after the water. So it creates a directory called Voss. And if we look inside of the directory here, you'll see that it creates its own GitHub repo automatically because Git's the default. You can use different reversion control systems with it, but it defaults to Git. It creates a git ignore that ignores things in the target directory, which doesn't exist yet, but will be in a second. That's the directory where the built executable is going to. It's got a cargo file here that holds things. What version are we on? We're up to version 1.2, whatever edition. So version 1 of Voss. Okay. And then inside of here, you can also put your dependencies for different crates and things like that as well. So what's cool about this is that, watch, cargo build makefile automatically made. Neat. So it just builds it for us, and it builds it in debug mode by default. If you do -- release, then it builds the optimized version. So like in C++, projects, we usually have two different ways of compiling our project. One is debug mode. The other is release mode. Debug mode has -G turned on, optimization turned off. Now fuzzy, because I stood up, how dare I? Okay. Still a little fuzzy, huh? And when we compile in release mode, we turn on the optimizer, we turn off the debugger, we turn off address sanitizer, things like that. So this is just almost like hard-coded, into the ecosystem because it's just so common. And so a lot of, maybe there's a downside to that. In C++, you have a lot of control over how you build and how you make and what flags you use and things like that. And you could still do that here, but it just has defaults that you'll hear me say this a lot, make a lot of sense. And so if you just say cargo build, it automatically compiles all of your things and builds your project using debugging information turned on, no optimization, debugging turned on. And if you compile it with -- release, then no debugging and optimization. And it's just a really nice default. And you'll see that there is now a target directory that wasn't before. And inside of the target directory, you will see there are two subdirectories, one for the debug release. And this thing is just not focusing on me. One for the debug version. And there's Voss there, hello world. That's the default. It creates a hello world for you. And there is a release version that also has a Voss. Look at that. Hello world. Look at how much faster it was. Oh my gosh, look at how fast it is. With optimization turned on, that hello world came out so much faster. It's incredible. But here's the cool thing. We actually don't need to go into those directories. Just watch this. If I type cargo run, it runs the It just runs the executable for us. And we can run the optimized version if we want. And guess what? If the thing doesn't exist, like watch this, cargo clean. Remember how there's always like a make clean in most make files that wipes the target directory out? If I type cargo run release, it automatically builds it, then runs it. So you don't actually even have to really say cargo build, you know, if you don't want to. You can just cargo run every time. And if it doesn't exist, it builds the things that need to be built. And it'll, there we go. I don't know. And it'll run it. And if you want to just check to see if your code's going to compile, there's cargo check. And that'll just check to make sure your code compiles without actually running the code also. So, without building the executable. So cargo build builds the executable. If you don't actually care about the executable, like I just want to see if my code's going to compile, you can run cargo check and it'll just check to make sure that everything is going to compile, because it does take a little bit of time to produce an executable. So let's do cargo clean, cargo check, 0.15 seconds, cargo build, 0.3 seconds. So you see it's about twice as slow maybe to actually build an executable. I mean, it's 0.15 seconds, nobody cares. All right, cargo vroom, exactly. So inside of the source directory here, you can see that there is a file called main.rs. Sound familiar? Probably should be. And look at that. So you might notice there's no includes up here. That's because in Rust, there is something called a prelude that they just are things that are included for you for free, which again, the defaults are really nice. So the defaults in Rust are fantastic. Thank you, honey. Onegaishimasu. Yeah. Got some Cali roll here. And so it's just like, hey, you know what? You probably need to like see out, you know, that's probably something everybody needs. So it just is included for you. So the prelude in Rust is a list of things that every package, you know, every program gets for free included. Now they don't want to make it too big because they'll slow down compilation. But as new versions of Rust come out, like they come out with new preludes that kind of modify the stuff that is included for free. And there's different preludes you can include to get whole sets of includes and things like that. So let's talk about language. So in every language, there's variables. There's, you know, the 6 or 7 pillars of computer science that I always talk about. So let's talk about variables first. Variables in Rust are kind of weird if you're coming from the perspective of, I don't know, let me just show you. So let is how you make a variable. This is fairly similar. If I say auto x equals 5 in C++, this is very, very similar to let x equals 5. Okay. This is very nearly equivalent, except in Rust, look at how I do comments. Oh, it's the same. Look, there's a semicolon. Oh, it's the same. Oh, there's curly braces. Oh, it's the same. There's a lot of similarities. The main difference is everything in Rust is const. This is very similar to saying const auto x equals 5. That is basically a complete parallel, right? It determines the type from the right-hand side and feels like math with a let x equals 5. Yeah. Probably some math guy came up with that. I don't know. Let x equals 5. But this is like the C++ equivalent right here. Notice there's no type. It'll deduce the type the same way that auto deduces the type. If you want to give it a type, you put a colon there and do that. Okay. And let's do cargo build. Unused variable x. Yeah. So there's this is also something that is good and bad. Good and bad. If you have dead code, that's code that you wrote that isn't called anywhere, it'll warn. It'll be like, hey, you wrote this thing that's not being called. If you have, does it deduce the type well? Yes. Pretty well. I would say it would be unnecessary to write this. You know what I mean? And in fact, if you try doing something like, let's make it a float. Okay, it's a float 32 now, right? If we try doing this, it won't compile. And you're like, wait, in C++, I can set a float to 5. There's no problems with that. Welcome to Rust. In Rust, if you convert an integer to a float accidentally without a explicit casting operation, compiler error. There are very few type conversions that happen automatically. If you go from, the other way around, if we try having like an integer that's set to float, doesn't work, right? Like in C++, it'll just happily like chop the decimal point off. It'll warn. It's like, hey, by the way, you had a 5.1 and you're losing the 0.1. In Rust, it's a compiler error. You have to explicitly cast to and from an integer to a float, and things like a char and things like that. Like it won't do it for you for free. C++ will very happily, chop off decimal places, narrow and overflow and things like that. In Rust, you have to be deliberate about it. You're like, I know what I'm doing. Trust me, as I32. That might work. Yeah, there we go. So this is how you can cast, by the way, in Rust. So I'm saying treat the number 5.1 as a 32-bit integer. And then it's happy. Yep. What other types of integers are there? There is I64, 64-bit integer. Note that this is similar to... in C++, we have int and long, but they kind of suck because int kind of means 32 bits, but it doesn't have to be. And long kind of means 32 or 64, depending on if it's Windows or Linux. And then long is 64. And so typically in C++, we will use uint 64t if we want an unsigned 64-bit integer. Like I personally prefer using, like very explicitly, this is how many bits that I want. So I don't get surprised if I move to a system that has 16-bit integers, which I'm not aware of any that have been made in the past 20 years, but it could happen. So in C++, you can make a, uint 64, uint 30, uint 32, things like that. It's very similar in Rust. It's just called I64, I32, U32, unsigned 32-bit. In fact, when I do C++ coding, I usually create type aliases for these things. So I'm just used already to typing U32, I32, because I like knowing how many bits that I have very precisely and not being surprised by a long getting wider and shorter when I move between Windows and Linux, which is terrible. So, in Python, and see here, it doesn't like this. It does not want a I32 going into a U32. No. Doesn't like it, right? Welcome to Rust. You have to be very explicit about how you do this kind of stuff. Okay. So what other types of things are there? There's char. Chars are actually 4 bytes, sort of. Chars are UTF-8. Let's put it that way. So we can do char equals, cat astronaut. Cat ninja. Just go with that ninja there. So, oh yeah, you might notice this here. If you put an underscore in front of the name, then it shuts up the compiler, the warnings, right? So if you're making a variable and you're like, yeah, I'm going to use it later, just hush. Like you can put an underscore here, and then it shuts up the warning. So that's pretty common. Like when you're like, I just want to just leave it there. You can just put an underscore in front of it. Then once you use it, like we say println, printf, println, that, underscore x. Then you can actually drop the underscore. And println, exclamation mark. And there, Voss. this? Yeah, cargo, so cargo run. Alias A to be cargo run. And there we go. So we got our ninja. All right. So if you want to print a variable, by the way, this is how you do it. Another way you can do this is you can actually just put the variable right there inside of the curly boys. That works just fine. And we will run it. Works fine. Okay. So yeah, unused variables, things like that. You can toss a little underscore there and it'll push. Does Rust avoid any of the C++ issues surrounding unsigned ints? So if you it'll kill your program. Like if that yes and no. Like if you underflow, it'll die, right? Like let's see if we can do this. Let's do like a unsigned 16-bit equals 0. This is const, mind you. It's like, let's see what happens if we try subtracting 10 from it. First of all, it's a constant stop. It's not going to work, right? So count assigned twice to immutable variable x. You guys see that? Every variable by default in Rust is immutable. It's a const. Can't change. So this is nice. This is actually a really nice default because in C++, there's kind of this general guidance that anytime you can const something, you should const it for various reasons, for safety. Sometimes it can help with the optimizer. But we can't change this because this guy's const. So what we have to do is we have to put the word mute there. So mutable means it is not a constant. So regular variables in C++, this would be equivalent to saying, unsigned short x equals 0. This is basically a regular variable. Okay. Thread main panicked. Attempt to subtract with an overflow. You see that? So this is, is this what you were asking, Olson? Like, does it handle the issue involving, unsigned integers? Well, yes. It detects it and it kills your program, which is probably good. Like, it's probably a good thing. Better than C++, which will just silently wrap around to max. And yeah. If you have UBSAN, it can help with that. So settings, Rust. Run this again. And so we get a backtrace now. So panicking.rust, panicking Rust. So on line 5, we have died. And so, what is it? Set? No. Hazelton, how do we turn on line numbers? Line no, set line, show number, set number. There we go. Okay. Yes, line 5. You guys see that? So Rust will be like, yeah, here's your problem. That's, you underflow it. Sucks to be you. Don't do that. So Rust calls these things a panic. So anytime you do something that violates safety, Rust panics. It's like, right? I'm panicking. And it'll panic a lot because, we do a lot of things that, like, you go out of bounds in an array and things like that. It's like, and it panics and it kills your program. But there's ways of handling that and stuff like that as well. Okay, so what else can we say about variables? There's no plus or minus. So if you want to do an x++, run it. X++ not a valid. Rust has it, like, it actually tells you, hey, C++ guy, there's no plus operator. This is not C++ anymore. It's C plus equals 1. And so it'll actually tell you, hey, fix your code to look like that. That's how you do it. And if I let's see if I can get a better error message in here. Or of course there is the x minus equals -1. right? That's the superior thinking man's way of doing x++. Oh, it doesn't work, right? It's unsigned. Too smart. Too smart. Fine. There we go. So it's 0 plus 1. Okay. What else can you say about variables? Strings. There's strings. Work basically the way you think. Name equals Bill. Let's see here. Oh. Yeah, just let name equals Bill. It's good enough. And unused variable, unused variables. I don't care. Okay. So Bill. Okay. See Hansen. So all these like unused variable warnings are kind of annoying me. So wouldn't it be cool if I could just tell the compiler to just like shush, you know, like I don't care, I'm good. Like just stop already. So you can actually put this at the very top of your code. And so this says, I'm going to allow dead code and unused variables and stuff like that. So this is similar to pragma, GCC, diagnostic, ignored, unused variable, something like that. So in C++, if you have warnings turned on, you're like, look, I know I got this variable, I'm not using it, just chill. You know, you can slap pragma, you can put that line right here above your unused variable, and then C++ will hush about it and not warn you on that unused variable, even if you have warnings for unused variables turned on. So this is very similar in Rust. You toss that at the very top of your code, and then it will stop yelling at you if you have unused variables, like I do now. And that's nice because I'm just going to be demoing code to you, and I'm going to get really tired of it yelling at me. You're not using this variable. I know, just chill. Okay. There is a void type also in Rust. So we could let Voss equal void, like that. So Voss is the void. Println. And you can see here, you can't print out the void. You look into the void will stare back into you. But you can pretty print it. So that thing there, it's kind of cool. So if you have a vector, or if you have an array or something like that, by default, you can't print a vector, you can't print an array. But if you use the pretty print thing, which is that thing that you saw maybe real fast right there, that little colon question mark on the inside there, that means pretty print it. And so it'll actually iterate through the for loop and print out the whole thing with square brackets and put commas in between them and stuff like that, which is kind of cool. It's kind of neat. It'll work for classes. You can, if you make a class and just say, hey, pretty print this class, it'll just print all the member variables and their values and stuff like that. It's just kind of cool. It's kind of cool indeed. It's like let's look at a vector. So a vector in Rust is made like this. Vec new. So that creates a new vector. A vector of what? I don't know yet. So really, the Rust language allows you to make a vector that has no type information. It actually will figure out which type it's holding when you first push data into it, which is kind of cool. It's the type is actually like an underscore, like it's angle bracket underscore. Like it's I don't know. You tell me what's coming down the pike. I don't know. You know. And so if we try pretty printing this thing right now, I don't know if it'll work. Yeah, I don't think it'll work. Type annotations are needed. Yeah, okay, fair enough. But if we do vector dot push 10 into this, then oh shoot, I got a good error message. Yeah. That's good. Yeah, let me take this back out. I was hoping to get a good error message, because one of the really cool things about, there's many really cool things, but one of the really cool things about Rust is that the compiler actually has a explain this error message to me functionality, which is so cool. It's so neat. Like, you're like, what do you mean? Like, what does type annotations needed even mean? Well, you just right click and hit return, and then it gives you like a whole screen full of information on that bug specifically, so you don't have to like Google it and stuff. Like it has examples like, hey, you can give a type information here with angle brackets, or you can do it here. Put it on the right hand side, you put it on the left hand side, blah, blah, blah. And you do the underscore thing is, and it has like an essay, and it like explains the error. Like, it's like so good. It's so nice. Like, I've gone through several of those, like in the last couple of days, and I'm just like, oh, this is really helpful. It's really nice. Really, really well written. Why doesn't G++ do this? I don't know. Like, that's literally like easy peasy for G++. It's like, hey, you're doing this thing wrong. Here's a paragraph about what you're doing wrong and why you shouldn't do it. So come back in here. If we push the value of 10 into here, then it can deduce the type kind of retroactively, right? So it now figures out, oh, I'm a vector of integers. Cool. And so we can go ahead and toss some numbers in here. 20, 420, 690, whatever. And if we build it, look at this. It has the ability to just print out all the elements in a vector. Cool. I don't have to write a print function for vectors like I always do, or write a range base for loop where you do all this kind of stuff. And it has like commas. Look at that. It's got commas between them. It's got square brackets at the end. It's so nice. It's just so nice. And that works for arrays as well and things like that. But vectors are great. We all know vectors. We all love vectors. So that's how you knew a vector. Okay. Now you might be like, well, we're not deleting. Yeah, it's got a destructor. It cleans itself up. One of the really cool things about Rust is it has really good guarantees on the lifetime of an object. So lifetime of an object is like when it begins, when it ends, it knows. And if you ever try doing something like preserving a variable outside of its scope so that it goes out of scope, but you still have a pointer to it here, doesn't allow it. It's not a runtime error, it's a compiler error. The compiler will not compile your code if you have a lifetime violation. Like, let me show you in C++ what I mean by that. So we got a function here called foo, and we got integer pointer here, and foo has integer x equals 420, whatever. Call foo, say pointer is equal to the reference x. And we want to see out the value pointed to by point. Cool. What's wrong with this code? You guys have been real quiet on chat. Nobody said anything for 7 minutes. What's wrong with this code? I'll pause the recording so I can drink some of my boba. All right. So the problem is that we are taking a pointer to a stack local variable. So x is only in existence between this curly brace and this curly brace. Once we return from foo, pointer, or putter as Arthur Dwyer puts it, is pointing at somebody on the stack that has been deallocated already. So we have a dangling reference. And so if we compile this with no, anything, no, A dot out. Here we go. Thank you. It works, right? This is the terrifying thing. Like, it worked. Shouldn't have worked. And it worked. And so you test your code, like, yeah, pass the test case. It's fine. No, this is horrible. This is like unimaginably dangerous, horrible, terrible, bad nonsense. Like, you have a pointer at something that's been erased. And so the next time you do a function call, like, let's do another function call here. Void bar. For I equals 0, I is less than 10, is plus. If we call bar And then we output the value pointer. Let's see if it's still there. All right. Still there. Still there. We're getting lucky. And that's the really dangerous thing. Every time I ran it, I got the correct answer. But this variable has been deallocated, and we're accessing RAM that just happens to still have the number 420 still in it. Okay. So if I compile this code with -f sanitize equals address.cc, you will see address sanitizer picks it up. You are using the stack after you've returned. You've returned from a function. You still have a pointer to that stack allocated variable. Rust is very good about this kind of stuff. Rust will be like, nope. And it's not a runtime problem. It's a compiler error. The compiler will not allow you to preserve things with a shorter lifespan into a longer lifespan. It just won't compile. You can take things from a longer lifespan and pass it to something with a shorter lifespan. That's fine. You can't use it to extend the life of an object after it's been deleted. So this is a really nice thing that you get kind of for free when you do Rust. You don't have to do any sanitizer checks or anything like that. It's literally impossible to try to preserve a variable like that. So, okay, so we got our vectors, so variables. Yeah. Main thing about variables is that they're all const. Use mute to make them mutable. So if you try doing this, where you just make a vector, you'll see not mutable. Can't do it. So you will get reminded. You need to make this thing mutable. And if you want an essay on the problem, look, here's the answer. Okay. So it tells you, gives you a nice little explanation of the problem. Arrays, I guess we should go over. So if we want to make an array, we can make a array equal to I32 of size 5 equal to 10, 20, 420, 690, negative 10. That's 5, right? So that's how you can make a array in Rust, and I think you can probably omit the type information on that. Probably just do that. I think. Yeah, works fine. So if you explicitly want to say I'm making an array of 32-bit signed integers of size 5, you can do that. It's fine. But it'll deduce that you wanted an array of 5 integers from the right-hand side, so you don't have to do anything crazy about that. There's these things called tuples. So Tupelo, Mississippi, equal to Bob and negative 420. Let's see. And so a tuple can hold different types. And so a tupelo is a tuple. The first element is a string, and the second element is a signed 32-bit integer. So you can just make a tuple like that. It's kind of cool. You can unpack tuples, pull things out of them. You can iterate over arrays in various ways. Arrays are actually really cool in Rust. It's like a pair. Yeah, but in C++, there's actually a tuple like class that because you can add like let's slap a float in there, right? So in C++, there is the tuple class. Thank you. Say tuple. What is it? String int float tupelo equal to Mississippi MISSI SSI PPI -100 and 3.1415. Okay. So you can do that in C++ as well. Yeah, good. With warnings on, it is going to warn you about this, but it's valid C++. In Rust, it'll be like, won't compile. It just won't compile. You can't extend the lifespan like that. So yeah, anyhow, this is how you do a tuple in C++. And so a tuple holds as many elements as you want of different types. It's kind of like a array, a heterogeneous array, if you want to think of it that way, where instead of having, you know, everything in an array is the same type, right? In a tuple, you can have elements, each one with a different type. So, and you can access them almost like an array. It's a little bit weird looking. Marshall, the guy who wrote the standard library, said that tuple almost killed him. Like it like pushed the boundary of like what it was possible for him to do, and it looks like a very simple class, but he said it was actually extremely difficult to implement. Let's see here, get. Yeah, there we go. So if you got make tuple, you can get angle bracket 0, angle bracket 1, angle bracket 2. So that's how you get the individual elements out of a tuple. Like I said, it's like a array, but a little bit different. And you can get the integer, you can get the constant char, you can get the double out of it if you want, like that too. So yeah, those things are in C++. All right. Nope. Okay. Yeah, a pair. Well, a better way of putting it, DOS. I mean, you are correct. A pair is a specialization of tuple. So a tuple is the generic. You can have as many, you know, things in the class as you want. A pair is specifically a 2-element tuple that is used in a lot of things in the standard library. That's why the pair class is found. You have to hashtag include tuple. No. Sorry. Pairs in utility. So weird. I think it's in utility. Let's do the pair. Yeah, it's in utility. It's so weird. Why is it not a tuple? Yeah. A pair is a specific case of a tuple with 2 elements. But it's not in the tuple. Anyway. Yeah, basically, yeah, but you're right. The syntax is a little different because with a pair, you have dot first and dot second. Instead of, you know, having a generic get, you know, get element 0, get element 1. Very true DOS. Okay. So that's the thing. Yeah, this is the pretty print thing. If you don't use pretty print like that, it will get mad at you. It's like, I don't know how to format these things. But then it tells you like, hey, by the way, it's pretty print thing. And so the pretty print thing will just create like a default way of printing classes and arrays and vectors and tuples and things like that. But if you're just like, I don't care, I want to debug my thing, just go. Like, it's really nice. It's just nice having that by default. I wish vector in C++ had a double left arrow operator. That would be nice. So I could just double left arrow a vector to the screen. It would just pretty print it like this for me. It'd be nice. It's just quality of life stuff. And unfortunately, I was having a conversation with somebody who believes that like quality of life stuff doesn't belong in the standard library. C++. We should be focusing on the important things, not quality of life. All right, how do we cast? I kind of showed you guys that already. You can use the as thing. But doing string conversions is a little bit weird. let name equals 1, 2, 3, 4. And I don't want to call it name. Let social security number equal 1, 2, 3, 4, 5, 6, 7, 8, 9. So you might want to say like, okay, I want to let my, you know, social security number be like SSN as I32, right? Like you might want to try and do that, right? Like just try casting the string to an integer. Println. Println gives you an automatic new line. Right? There's also print if you don't want a new line. I like that too. I like there. So it doesn't like that, right? So unfortunately, like it's a little bit annoying doing the string to int conversion. So you do .parse unwrap. So unwrap means that if an error occurs, die. And if we do that, type annotations needed. Dang it. Right. We want you to be an I32. Let's say, will that work? SSN should have a snake case name. It's so funny. Yeah, Rust has a specific like style guide that is official for the language. And so it like yelled at me for like, no, you should be not using, you know, all caps. You should be using SSN official. SSN. Make that go away. Okay, so you can see here, we were able to convert from everything snake case, right? Don't use all caps. You're going to get a warning. Now if I change this to like moose, like that, you will see we get a panic. Okay, so again, Rust goes ah, and it kills your program. So you know, whether or not that's good, you know, like if you're in like a mission critical thing, like I don't know if it's good, but yeah, it will just like no. Oh, he's only got 10 years to live. Pull the plug. Dialysis? Nah. Rust kills you. Rust is no chill. Like, it's like, die. Unwrap. Yeah, so unwrap kills your program if it tries converting to an I32 and fails. There's also, what was it, expect? See if that's the right word. Yeah, blah. So you give it an error message too. So string to and failed, you suck. Okay. So you can see right there, gives you a nice little error message to go along with your panic. Thread main panicked on line 8. And then it gives you a backtrace because I have the backtrace thing set up. It's nice. It tells you exactly which function called which function, what line you're on. You know, you died, this line. Yeah. So, okay. So, and there's better ways of handling that. But anyhow, so that's basically 90210. And if everything goes right, then you don't see that error message. That error message, you suck, only appears if the string conversion failed. He's also on the committee as well for C++. Somebody's planning to improve exceptions. That's good. On the committee for C++. Cool. Nice. You will like the professors at San Jose State unless you take the professor titled so-and-so because he's like Kearney. Whom he's really hard because he's like Kearney, but focus intentionally on the mathematical side, does programming assignments for good reason. I love it. Okay. But does he do workshops at 8 o'clock at night? Maybe. All right. What else can we talk about? So that's variables. That's quite a bit on variables, really. Floats, I guess. We can talk about floats. Kind of looking at my notes over here. So if you have let flute equals 3.1415, say let flute 2 equal to some I. It's gonna be like an I30, like an F32, F64. Flute. So converting from a F32 to an F64. So in other words, a 32-bit integer trying to widen into a 64-bit integer shouldn't be a problem, right? You don't lose any precision when you widen, you know. But it's like, hey, by the way, if you want to convert from a F32 into an F64, here's how you do it. It's like, cool. Thank you, Rust. Very cool. So you just say flute dot into. Let's try that. Let's see if that works. Not int. No, not with a 0. There we go. Dot into, and look, it worked. You know? And so when you try doing things, and it's like, oh, you're trying to do this thing that we prohibited because it doesn't make sense for us to allow different widths to go to each other for some reason. Here's how you fix it. Really nice. And if we do this the other way around, let's see, 64 into F32, then it says, by the way, we haven't written a conversion routine to go from F64 to F32. Neat. But we can do this. Flute as F32. That works, I think. There you go. So yeah, this is the casting operator, and you can just say, yeah, treat the 64-bit integer as a 32-bit integer. It works fine. It's fine. Yeah. Okay. And if you want to print multiple things, you do this. You can say println. You do this. Woo. And you can say flute. And you can see wherever you have these curly braces inside of the print string, it substitutes in the parameters here in the order they're provided. Was it like 2 and, or was it 1 and 0? Yeah, and so you can actually change the order that they print in if that floats your boat, or you can just like literally just put the name of the variable inside of there. Actually, how can we tell these apart? I don't know. Let mute flute 2 times equals 2. Okay. No, doesn't like it. Alright, let's make it a double. Give me trouble, make it double. Redundant arguments. Oh, yeah. True. Good. Okay. There we go. So you can see flute and flute 2, which is fine. Now you notice what I did there. I tried doubling the value of this guy. So that's a float 32. I'm multiplying it by 2. And to our C++ brains, we're like, that should be fine, right? Nope. Sorry, that's an integer. You can't mix integers and floats. Not allowed. So you just have to come in here and add a decimal. Now it's a float. Works fine. Okay. So there's a lot of things like that. Result types are pretty cool. Yeah, so with a result type, you can return something that is either okay or an error. And then you can do what's called a match, where you say if it's okay, you do this thing. If it's an error, you do this thing. It's kind of like a variant in C++, where you can return 2 different things, and you can check to see, like, did I get a okay thing or did I get an error thing? And you say, if I got a good thing, I do this one thing. If I got a bad thing, I do this one thing. And there's a nice little syntax for that in Rust. They have matching like that. Are there speed differences? The cool thing about Rust is that these safety guarantees are actually enforced by and large at compile time, right? So a lot of these guarantees you get are actually guaranteed by the compiler. So you don't even have to do the checks at runtime because the compiler is guaranteed that you're not extending lifetimes and things like that. Whereas in C++, you have to do a runtime check, which means while you're running your code, address sanitizer is like examining, like, oh, you're accessing that memory. That memory's been deallocated already, right? Which is slow, right? Address sanitizer slows your program down by like an order of magnitude, something like that. And with Rust, you don't have to do it because it's guaranteed that you can't, extend lifetimes and things like that. So, assuming that everything's running correctly, you should have no difference in speed between Rust and C and C++. But once you start turning on like address sanitizers and turning C++ into Java, which is what we do, like when I'm teaching CSI 40 and 41, I've got so many safety features turned on in C++, it runs an order of magnitude slower because I'm essentially turning C++ into Java. Every time you access an array, it checks, are you within the bounds of the array? Yeah, no, yeah, okay, it's good, go. Oh, you're not, die, right? Which is what Java does, right? And so Rust has the benefit of giving you a lot of safety guarantees without the speed penalty of having address sanitizer. And you can release your C++ code with the address sanitizers turned off and turn up the speed if you want. But now if something happens unexpected at runtime, you're toast, right? So, okay. So, yeah, so you can print multiple things at once like this. It's pretty nice. I like it. I like the print stuff. The input side of IO, I don't like. So I've been talking a lot of very positive stuff about Rust. Let me show you how you do a cin now, and tell me if you like this. So where's my notes on this? It's kind of sucks. Okay. So we're gonna have let mute name equals string new. So that's gonna make a new string. So we're gonna like ask somebody for the name, right? So we do like println. What is your name, citizen? And then we do the following. What is it? Might have to. I might want to import, but whatever. Let's just do it the long way first. Stood : IO : standard n is cin essentially, and you can do a using kind of thing. Like if you don't want all that stuff there, you can toss this up top and say use standard in, and now you just refer to standard in like that if I spell it properly. Okay. And then we can say standard in read line passing in by reference, passing in mutable, because remember everything's passed in immutably. So if you want to pass in something so you can change it by reference, because everything's const. Even when you pass something, it gets passed in as const, unless you specifically say you're passing it by const reference, non-const reference. Sorry, which is what we're doing here. So like I said, the defaults are different in Rust. Everything's const by default. So if you want something to change, you have to explicitly say not const. Whereas in C++, you have to add const to everything. So we're going to pass in by mutable reference, name, and then if it dies, remember that expect thing there. We didn't get the name or something. Okay. So this is going to read from standard in. It's going to read until the user hits return. It's going to put the answer into name. And then if an error happened, then it's going to print, we didn't get the name or something. Panic! Ah! And then we just do like println with exclamation mark. I know you. Name. And then what is your name, citizen? My name is Voss. I know you, Voss. Now you might notice something really annoying here. Whenever you do the read line, it reads the new line also. It's just like, I don't want it. I don't want the new line in the name. I just want the name. I don't want the new line. Why are you doing this to me? So it's already like kind of annoying. Like that's kind of annoying to do a single cn statement. And having to new the thing first instead of being able to read the value, like my read library, which is superior to Rust's ability to read. And C++'s. But what you have to do, let me copy and paste this code here. So if let some new line equals name chars next back name pop. So basically what it's doing, it's comparing the last element in name to new line, and if it contains a new line, it pops the last character off. And it's like I'm sighing visibly here. What is your name? My name is Voss. I know you, Voss. Look, no extra new line. No. So yeah, I am not a fan of how read is better. Yeah, read 2 is Kearney. Right, I should probably incorporate your code into it at some point. I don't want to toot my own horn, but also, it is better. It's... it is better. Okay. Anyway, so yeah, I do need to incorporate Voss's stuff into my read library at some point. But yeah, it just kind of like, look at that. Like that's seeing into name, right? Like that's... Now there is one thing I like. It's got a dot lines. So Megan in Python, you have the ability to turn a file into basically an array of strings, right? It's like what's the name of it? It's like read lines or something like that. Do you remember the name of that function, Megan? It's been a while since I looked at it. But in Rust, this is called dot lines, and so you can essentially say for each line in lines do something, and so you can kind of like range-based for loop over a file and things like that, which is nice. But it's like, come on, like this is, and this is, I think, their second approach like at it. Like I think this is actually the nicer way of doing input, which is not good. All right, and then you have to do that weird string conversion to. Yeah, not my favorite part. So let's talk about algebra, I guess. I mean, algebra is basically the same. I don't know if we care about this. Algebra, 6 pillars of computer science, 7 pillars of computer science. Algebra. It's like basically the same, but no minus or plus minus. So if we, you can times equals things. It's the same as C++. So let's talk about conditionals. So let's say we just got the name, and I don't want to input again. Password. Okay, let's just do an if statement. So we can say if name double equals Voss, then cout println access granted. Else if name double equals Kearney, super user access granted. Else println permission denied. Okay. So if we run this, yeah. Make it like return or something. My name is Voss. It prints access granted. If I'm Kearney, super access. Okay. Now, one thing that's different in Rust is you don't actually need the parentheses. You can put them there if you're comfortable with them. If you're used to C++, you can have the parentheses. You do that, but you don't need them. Works fine. What do you guys think of that? To me, it hurts my C++ brain a little bit. Like I want to put the parentheses there, and it works. Like it doesn't split lines. Yeah, thank you. myfile.read.splitlines. Yeah, it is like Python. Yeah, most definitely. I like the fact that it works both ways. Yeah, I like that. So if you want your code to look like Python, you can. I'm gonna have parentheses there. Maybe it'll yell at you. I don't know. Let's see. Let's see. Let's see if we put the parentheses here. Will it format? What's the name of it? It's Rust format. Rust FFT format. Rust. Do I just not have it on here? Maybe not. I don't know. But there's a program that'll format your code according to the official documents. Rust format. Install Rust. Okay, so Rust format. .rs. And so now it didn't change it, so maybe it doesn't care. But look at this. So you can see here, when you have a dot something, this is actually a fairly common thing that you'll see in Rust. Even things like arrays, like I mentioned earlier, arrays can do some cool stuff. You can have an array and then say dot filter and have it filter out some of the elements in the array, and it returns a smaller array. Arrays can also be sliced. So instead of passing the entire array to a function, you can say just pass elements 2 through 12 or whatever. And so whenever you can have a dot this, dot this, dot this, dot this. And so the official formatting guideline has each one of them on a separate line, so you can kind of follow it instead of having them all together. Otherwise, I think it changed anything other than that. Yeah. So anyway, can't do one line if statements without curly boys. I know there's a lot of languages that are like that these days. They're like, no, you must put curly boys on them. Yeah, just no accounting for taste. You know what I mean? Braces are used even when the body is empty or even contains a simple statement. Yeah. It's kind of like when I'm in Java and I want to use like not like with an integer. It doesn't allow it. You can't use exclamation mark with an integer in Java. And you're like, why? It's just, if it's 0, then it's true. If it's anything else, it's false. And it's like, no, you can't Boolean not an integer. That's impossible. So I do miss my C++ shortcuts, like for definitely. Now let me show you something kind of cool. All right, so okay, let power level equal watch this. So Voss's power level is 100. Kearney's power level is over 9,000. Oh, okay. And everyone else's power level is 1. No. I keep wanting to put a semicolon there. No semicolon. Okay? The semicolon comes here. Okay? So this should like hurt your brain a little bit, right? If you're coming from C++, does the dot operand in Rust work in order of object that came before? Yeah. It does each one at a time. And there's a new thing in C++ because we're copying this called ranges that allows you to do the similar kind of thing in C++. You take a a range, and then you can filter it, and then filter it using vertical slash operator and things like that. So anyway, but look at this, look at this, look at this. There's no semicolon here. If you have a expression, which is anything that can fit within smooth boys parentheses, with no semicolon at the end of it, then that's the value that gets returned from that if statement. So you can have this big complicated if, else if, else if, else if. All of the branches have to return the same type, by the way. And if it's Voss, then the power level gets set to 100. If the name is Kearney, it sets it to 9001. If it's anyone else, the power level is set to 1. And that semicolon here is because the actual statement is a let. So it's a variable initialization. Lets always have to end in a semicolon. So yeah, it's kind of cool. And we can print line the power level. This run it. Come to my alias. Oh, I reran my aliases command. Alias run. What's your name? Kearney. And okay. So yeah, this is also how you return from a function. What's up, bro?
I'm done with all my homework. Can I call my friend?
Yeah. Here.
Thank you, Father.
Catch. Hey, you got it. Good job.
Yay.
All right. She doesn't have. You have your own phone. I got her own phone for a trip to New York, so it's a time limited thing, but I think it's still up actually. Anyway, so you can't see yourself typing code like that. Well, the thing is, this is how you actually do functions. So we've done conditionals. I guess we can do loops, but while I'm on the topic, let's talk about functions. So functions are defined with fn, and the return type follows the thing. So let's make a function called foo, and it takes in a variable named x, the type i32, and it returns an integer, and we will what are we going to do? Square it or something? Times x. Look at that. Enough. Yep. All right. Yep. There we go. All right. There we go. Cool. Yeah. So long standing habit to type int. Trust me. So notice there's no semicolon here, right? We're not, just if you just have an expression on the last line of an if statement or a function or something like that, that's the return value. So this function, I guess we can call it something better than foo. We can call it square. And so let us square the power level. Now watch this. Let power level equal square power level of volt. Yep. Nope. I just killed the. Yeah. Did I? Yeah. Maybe. Yeah. One too many escapes. Okay, there we go. So if I type in Voss's power level is now squared, right? If I run mine, I am 9001 squared, which is massive amount of power. Power overwhelming in my fingertips now. Okay. So that's kind of cool though, right? Like you just whatever is at the end of the function is the value returned with no semicolon. If you put a semicolon there, then watch what happens. It's returning void because the very last expression in the function now is void, nothing. So whatever expression is at the end of the function or at the end of the branch is the return value. Okay. So it'll tell you, help remove this semicolon to return the value. And if you want an essay on this, you can read an essay on it. Right? This is how you return a value. You know? They do have return. So you could return x times x, I believe. Let's see. I don't see what's wrong with that. You can, like, that's just plain old C and C++. It works fine. Works fine. But it's got this interesting syntax that if you just have something without a semicolon, that's the return value. Okay. Kind of neat. I don't know. You know, my C++ brain would probably just write that code, though. All right. See you, Megan. Yep. If you don't return anything, then you return void, or you don't have to specify anything at all. You don't have to take any command parameters either, if you don't want to. But basically, it's the same as C++. The main Vim. Okay, good. The main difference, like with everything in Rust, is that the name of the variable comes first, then you have the colon, then the type. So it doesn't take long to get used to that, and there's probably good reasons for that too. But I'm used to typing integer x, and said it's x colon I32. It's the same thing. It really doesn't take that long to kind of get used to Rust after doing C++. So the last main thing that I want to cover today, because we're already an hour and a half in apparently. Loops. And I forget something. IO. Yeah, kind of done IO. Classes. I'll do classes. Okay. Classes are a little bit weird in Rust. They have associated functions and stuff like that. But they have structs. Like if you, let's do a struct real fast. Structs. Let's make a struct point. There's a semicolon on it. X I32. I32. Okay. All right, and there's no semicolon at the end of it. So if you want to make a point, well, we come to the point here. If you want to make a point, you just say point p if you want, and then you can say p dot x or whatever. 10. I believe that works now. Selected one of 8 possible tokens. Let me see here. Oh, right. Back to C++, am I? All right. Let's do this in Rust. Let p point. You don't have to initialize things if you don't want to. I should do it now. Partially assigned here isn't fully initialized. Fine. We'll just do it the correct way. Equals x is equal to 10, and it's a semicolon, comma. Y is equal to 20. There. And let us. Fine. I don't think this is going to work actually. So by default, you can't print a struct. You can, however, add a little bit of magic where it will automatically allow you to do this kind of stuff and copy things and clone things and stuff like that. So you can slap a little line here like that on top of it, and then it works just fine. And look, it automatically printed my point class for me. The name of the class, curly boys, the variable name, the member variable name, the value, comma, the other member variable. So there's a little bit of magic that you need to slap on top of a class or a struct in this struct that will allow it to work like a pod in C++. By default, structs, if you don't have like the copy and the clone and things like that on it, let me show you what happens here. Debug generates the automatic pretty printed thing for you, like that, which is nice. All right, that's fine. Let me do something interesting here. Okay, that works fine. Let's see if we can copy. Let Q equal to P. Yeah. Okay. So this looks like it should be fine. Okay. So when we're doing something like this in C++, C++ will generate a copy constructor for us, and it will automatically copy P into Q. All the values get copied. In Rust, by default, it does not copy a value. Instead, it moves. So in C++, we have something called a move constructor where you steal the inner guts of one class and put it into another class. So if you have a vector, and the vector is going out of scope, but another vector is copying the values, C++ will do a move constructor and actually grab the pointers. The inner guts of the one vector get sucked out of its belly and put inside the guts of the other vector. So instead of having to copy all billion elements of the vector, it just does a little pointer math and copies the things out. By default in Rust, it moves everything. And so when we have this, we say let Q equals P, this moves P into Q. So P is now invalid. We can't do anything with P ever again at this point. And so what happens is that here we are trying to use a value after it's had its guts sucked out of it. And then we're trying to use it and it doesn't allow. So if you want the struct to behave like a C++ struct where it'll just copy the values, then you have to do this little bit of magic here, and that will automatically copy, automatically clone, and generate a little pretty printed thing. Now we've got something that behaves just like a C++ pods, plain old data structure, plain old data thing, and that should work. There we go. Okay. So now instead of moving, it is going to copy. You guys see that? So in Rust, the default is always to move. The default is never to copy. In C++, the default is to copy. Copying is slow. And so again, Rust has better default settings than C++. If you expressly, super duper want it to just copy every time you do something like that, then you have to tell it, we want this just to copy. It's two variables, we don't care, that kind of stuff. So, C Hazelwood. The lack of consistent semicolons everywhere. Yeah. So, so that's structs, at least the simple thing. There's a lot more to it. Gotta go. Yeah. So I'm almost done. We got one last thing here, which is loops. And so looping time. there's a couple different ways of doing loops. Check my notes over here. Let's see here. I guess we can start with fizz buzz. That'd be kind of fun. Okay. So let's do fizz buzz. So you can say for n 1 to let's do 1 to 100, which is going to be wrong, but this will be interesting. Okay. Let's just start off by doing println. So look, I said go from 1 to 100. So you can see that the first number up here is 1. The last number is 99. That's kind of weird, isn't it? Like, you're like, wait a second. I thought you're doing the range from 1 to 100. But as it turns out, just like in C++, where we have the half-open code pattern, where it includes the 1, doesn't include the 100, that's the default in Rust as well. So if you want it to go all the way up to 100, you put an equal sign here, and then it's going to go from 1 to 100. So if I recompile this, you'll see it now goes up to 100. Okay. And so if we want to do a little bit of fizz buzz action here, we just do a little if statement. If we use parentheses or not, I guess, yeah, whatever, we're C++ people, we'll use parentheses. Okay, so if n modulus 15 double equals 0, look, it looks just like C++. Else if n modulus 5 equals 0, else if n modulus 3 equals 0, else, so that's fizz buzz, and we just need to print fizzy buzz, fizzy buzz, fizzy buzz. That. If we get a 5, it is buzz. 3 divisible by 3. Is you guys all familiar with fizz buzz? It's a drinking game that's also somehow become the de facto programming interview filter question. So we got this guy here. Okay, so that's fizz buzz. That easy. Okay, the 1 is the power level. It's not our 1 here. So it goes 1, 2, fizz, 4, buzz, fizz, 7, 8, fizz, buzz, 11, fizz, 13, 14, fizz, buzz. So that's it. Fizz buzz in, I don't know, a couple seconds. Not bad. But this looks a little different, right? Like for n 1 to 100. It's a range. You can also do a range-based for loop across an array. So if you have, did I delete my array? I think I did. Let's go here, I guess. So if we have let r equal to 10, 20, 420, 690, -10. Miss fizz buzz's simplicity. We can say for I x in r dot iter dot enumerate this print line, there we go. Index I value of x. Like that. You see here, it'll print out index 0, value 10, index 1, value 20, index 2, value 420, index 3, value 690, index 4, value -10. So, iterators, they have iterators in Rust, just like in C++. It looks a little different. Arrays in C, which is what we inherited in C++, aren't classes. You can't do anything with them. But in Rust, they have member functions and things like that. So you can actually grab an iterator to, the start basically of the array. Then you say enumerate, and then that creates a range. And then the range-based for loop just runs down the range and it returns two things. A tuple consisting of the index, so you know where you are in the array, which is nicer than the standard range-based for loop in C++, which only returns the value. In C++, it only returns the value of the array. In Rust, you get both the index and the value at the same time, so you know where you are, and you can be like, oh, the max index is at 7 or whatever. So, kind of cool. Yeah, it's neat. It's pretty neat. So that's loops. There's also while loops. There's while loops. There's where's the I don't think I have while loops in my notes, but basically is what you would expect, I think. So you do while I is less than 10, let mute I equals 0. See how the world. Hello world, I plus plus. There's no I plus plus. I plus equals 1. Ah. And there you go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's a while loop. Looks just like C++, right? Like, yeah, it's exactly the same. The only difference is you don't need the parentheses, of course. You leave those off if you want your code to look more like Python. It's exactly the same. I'm a C++ guy. I'm putting the parentheses back on. It looks more familiar to me that way. I think I've kept you guys here long enough. Let me check my notes, see if there's anything else I want to talk about. You can iterate across a vector, which looks basically like that. If you want to modify things, you can use a mutable iterator. So there's something called iterator mute, like this, iterator mutable like that. And then I think you have to do like mutable. Not borrow is mutable because array is not mutable. There you go. So if we do an x minus equals minus 1, then it is and So we added 1 to each. So basically with this range-based for loop we got here, you can use a mutable iterator. You have to make the array mutable. You have to put a mute here and a mute here and a mute here. And it gets kind of annoying when you actually want variables that are variables and not constants, because like I said, in Rust, everything's a constant by default. So you have to kind of like go down the line like, okay, you need to be mutable, and you need to be mutable, and you need to be mutable, because if you leave off any of those, then the thing gets mad at you. If the array is not mutable, right? If the array is not mutable, you can't take a mutable iterator to something that's not mutable. So it's like, nope. But it tells you how to fix it. That's cool. Right. And then if you don't grab a mutable iterator, it's probably going to go you for that. There you go. So the data cannot be written. So you have to make that an iterator mutable. And then if this isn't mutable, then that actually worked. All right, so that's fine. Okay, so we got it. So x is mutable because it inherits that from the right hand side. Okay, great. But basically, you have to just kind of, as you go down as you go down the line, if you make a mistake, it's going to be like, nope, you can't use it on a reference. You have to dereference. So you're like, okay, all right, fine. So just getting something as simple as like adding 1 to all the elements in the array just has 3 different points along the way where you have to like do it. But that's, on the flip side, in C++, I put the word const everywhere. Right? In C++, I const all the things. Constant methods, constant parameters, constant variables. It's all over the place. And in Rust, you don't have to do that. Instead, the things you do want to change, you have to mark as mutable. Which, in cases like this, it does get slightly annoying, because there's like, yes, you have to change. Yes, you have to change. Everybody has to change. Everyone's okay. All right. It's a slight annoyance. It's not the end of the world. It's just different defaults. You were asked FizzBuzz's interview question if you pretty much already have the job and have to go through the interview as a formality. Not necessarily. Like a friend of mine applied at Facebook, and they went through 5 rounds of technical interviews. The first round was FizzBuzz, and that was just so like if you can't code FizzBuzz live in front of somebody, out. Like, don't bother wasting the rest of our time. If you can't code FizzBuzz in a reasonably short amount of time in front of a live studio audience, just go away. Like, we don't want to, like, no, go back to school. So, it's a good filter. It doesn't get you the job, but it will get you not the job if you can't do it. So, right. Okay. So I think it's everything I kind of wanted to cover today. There's more. There's matching, which is kind of cool. And the classes kind of stuff is kind of cool. And the borrow checker is annoying, but it's good. Lifetimes are really important, but I think this is like the basics of the language. Basically, whenever I teach computer science, it's like, if you can get the basics down, that's all it takes to really kind of get going, right? And then when something happens, you're like, oh, okay, look it up, stuff like that. So Olson said there seems to be a lot of things to memorize, not as many as you think. Not as many as you think. The while loops are the same. The types are a little different. Yeah, the mute's a little different. Println, like, that should be easy to memorize, I think. That's the same. That's pretty much the same. It's a little different, I guess. That's a little bit different. That's definitely different. Yeah, okay, fair enough. Yeah. That's different. Function calls are the same. If-else if is all the same, except that's different. Yeah. Let, that's auto. I don't know. Like, I feel like you're right, Luke, that you do have to kind of like, memorize some stuff. It's definitely not as close as like Java would be. With Java, you could literally take C++ code and just run it in Java. Like core C++ code. Like core C++ code meaning no stud, no standard library stuff, just the language itself. Like, you can, maybe not with chars. Like, there's some exceptions, but by and large, like, you can take just a for loop in C++ and it'll run in Java, right? And you can just take your C++ code and just put it in there. And there might be some small differences. We have to clean up a little bit. But Rust is, it's pretty close, honestly. Like, it doesn't take long to get used to typing fn for a function. Like, it's still a curly brace language. It still has semicolons at the end. Like, you saw me when I'm typing this. Like, I just default to C++. I'm like, oh, it's not Nginx at all, is it? It's not cout. But it, like, legitimately, it's not that big a jump. There's some things that are definitely further away from C++ than I would maybe like. Like I don't like how they do CN. That's probably the only thing I don't like about it. Some of these things, like they love these filter things where you have dot this, dot this, dot this, dot this, and that isn't necessarily my most favorite thing in the world, doing filters like that. But, the formatting for some of the variables. Oh yeah, I guess I should talk about that. There's you can add a suffix to all of these variables here. And no. What's going on? No. All right, I give up. 8. Right. So now it is an array of unsigned 8-bit integers. So basically, any number can have a suffix on it, and you can also put an underscore if you want. If that makes you happy. Doesn't do the underscore doesn't do anything. All right, can't be a negative. 420 is too big, right? So you see that? Like, it's nice. Like C++ might very well let you overflow that, but an 8-bit can't hold 420, right? So okay, so it catches the error, and so you can have it be an unsigned 128-bit number. They do have 128-bit numbers if you want. Really big numbers now. 128 bits, the biggest they have. Yeah, so there's suffixes for all the different numeric types that you can. It's like here you're going to get, I think, an int by default, but if you want, you can make it like a 32-bit float, something like that. So there's suffixes for all that stuff, and it might take a little bit of time. I don't see it as being really that hard to get, because in C++ there's suffixes like that as well that you can tag onto things. And yeah, I think we're good. I think it's a good starting point for you guys. And so let me tell you guys about the Rust opportunity. If you wish to have extra credit in your class, rewrite any of your homework assignments in Rust. It can't be a trivial program. Like last time I made an opportunity like this, like somebody like did FizzBuzz. I'm like, well, you said any assignment. Not, yeah. So it can't be something trivial. I want to see like a little bit of work on your guys' part. But if you redo one of your homework assignments in Rust, pass the input tester. It's got to be something that has input testers, so you can guarantee the correctness of it. If you can do that, I will give you 10 extra credit points. So it's like you did a whole nother homework assignment. So that FizzBuzz TDD, no, Declan, no. Like there is testing in Rust. Like testing's actually a huge topic in Rust that I didn't even talk about. Tests are actually really cool in Rust. But not FizzBuzz TDD. No. Class Playground, no. Something more substantial than that. Not anything but FizzBuzz. It has to be substantial, because we had like Class Playground. We had a couple like little toy, get to know the programming language, kind of things. No. If you want to earn your 10 points, it's got to be something meaty, like do fractionation or imaginary homework. Like something that's got some gas to it. You're earning 10 points. When you have to write your own test cases, no, you have to pass my test cases. So Rust creates an executable. It's not like Java, right? It's like when you go into the target directory to get some cheap clothing, It gives you an executable. Like, that's actually an executable. It's not like in Java where it gives you like this interpreted bytecode thing that has to be run. You have to do like a Java, VOS, and like it interprets your. No, this is actually an executable. That's one of the really cool things about Rust is you get an actual executable. Unlike all these like Python, it's all interpreted scripting text. You get an actual program that's performant. Like Rust is a very performant language, which I like. Like I don't like how slow Python is, for example. Like, why are for loops so slow in Python? Like, deal or no deal is good. Yeah, deal or no deal is good. Not any past homework. No. It's something more substantial than FizzBuzz. Not ASM first. Like not Hello World. Like you gotta, come on, you gotta put some time into this. I'm giving you an entire homework assignment worth of extra credit. So it's gotta have some substance to it. And if you have any questions, just message me. Okay. By when? I don't know. How long do you guys want for this Rust opportunity? Figure your plans. Ask some SpongeBob. That's really trivial. Deal or no deal would be good. I don't know. If you're curious if your homework is substantial enough, see if it fits on one page. If it fits on one page, it's not substantial enough. Although that opens up people like spreading their code out over like 2 pages or something like that. RPG 40 in Rust. That'd be great. Chris Latner is fixing Python. A week. You want a week? I was, I don't know. It's extra credit, but how about by next Friday? You didn't even do C++. It's fine. We'll see by next Friday. So you guys will have like 10 days or whatever to redo one of the homework assignments in Rust. And like I said, you get your executable, toss it into your deal or no deal directory or whatever, run it, passes the test cases, screenshot it, send it to me, and you get 10 extra credit points. 3 weeks in networking. Volley Shipperty in Rust. Before the end of the semester, do I want to do that to you guys? Because what that means is that if I make the deadline the end of the semester, what that means is that nobody will do it before the end of the semester. And then during finals week, you're going to be working on this Rust assignment. I know. But like, it hurts you because you're studying for finals and you're like trying to do, this extra credit assignment while you should be studying for your Math 11 class or whatever, right? So, I think 10 days is enough, right? Next Friday. I think that's reasonable. So we'll set it to next Friday and I don't know, 100 days, 15 days, 2 weeks. Fine. 2 weeks. You have until the whatever that is, 16th. All right. At 11:59. Fine. Every last minute. Midnight on the 16th. Specifically, like 11:59. What about 59 seconds? Do I get the 59? Yes. I don't actually care about the deadline that much. I just don't want it to be during the finals week because it will hurt you guys. So it's for you that I give you deadlines. 59.99999. Honestly, though, like when I don't give students deadlines, they wait until the very end of the semester and try doing the entire semester in the last week, and it's a giant train wreck. Last year in CSI 41, I allowed infinite amnesty, so you could redo any homework assignment. And some students were like, "Well, what that means then is that there are no deadlines until Easter." And then whoever it is I'm talking about here, didn't do any of the work up until Easter, and then Easter rolled around. It's like, oh, I've got 10 homework assignments that I haven't done, and it's 11:50 at night. What can I get done in 10 minutes? You know, so. Yeah. So honestly, like deadlines are actually in part for you guys, you know, to give you like a target to shoot for. Like it needs to be done by now, so you get it done. Anyway, soapbox off. I'll give you guys 2 weeks to do it. Fine. 4/16/24 at 11:59.999 is the last moment that I'll take the Rust assignment. So I will put up into the public directory. It'll be a file called Rust demo. I've got it ready here. Rust demo.rs. Yeah. So rust demo.rs. And I already got it open. But anyway, so I'm going to put that file up in public, and then it'll have all the demo code that I went over here. Because when I was doing the thing live, I was deleting the code. All of that code is in my notes, which is this file here. And then you can look at it with amazement and shock and awe. Like, oh, Kearney's code is so beautiful. Oh, I'm so impressed. I'm feeling, blessed by the beauty of this Rust code here. And it'll be a spiritual experience for you. I'm recording it, don't worry. This is all recorded as well. All right, so that's it for guys. 2 hours of Rust is enough for me. Should be enough for you. Go take advantage of the Rust opportunity. If you're worried about passing the class, I would especially take this Rust opportunity to redo some old homework assignment. It doesn't have to be in your current class. It could be for earlier classes as well, as long as it's substantial. I don't want small things. All right, so thanks for coming out, everyone. Have a wonderful, beautiful spring night, and I'll see you guys on the flip side.